Okay, now that we have completed the discussion on calculating coordinates of center of mass using x bar is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, let us now try to understand how the same is derived using the formula x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Okay, so we know that the mass density, which is equal to sigma, is mass by area, right? Which is equal to m by a. Now we have x bar is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. The coordinates of the x coordinate of center of mass. And similarly, we have y bar is equal to the corresponding terms here m1 y1, m2 y2, m3 y3, m1 m2 m3, right? Now, if sigma is equal to m by a, let me just write down that stuff as well. Okay. So, if sigma is equal to m by a, from this relation, I can write that m1 is equal to sigma 1 a1, right? Similarly, I can write m2 will be equal to sigma 2 a2 and m3 would be equal to sigma 3 a3. One more time, we have m1 replaced by sigma 1 a1. How? Because sigma is equal to mass by area, and therefore mass is equal to sigma into area. And we have m2 is equal to sigma 2 a2, m3 is equal to sigma 3 a3. So this m1 x1 becomes sigma 1 a1 x1, m2 x2 becomes sigma 2 a2 x2, m3 x3 becomes sigma 3 a3 x3. The whole upon m1 is sigma 1 a1, m2 is sigma 2 a2, and the same applies for the y coordinate as well. So instead of m1, we can replace m1 here with sigma 1 a1, sigma 1 a1 y1, a2 y2, sigma 1 sigma 3 a3 y3, so on. Okay. Now, if we assume that the plate is of uniform density, then we know that sigma 1 should be equal to sigma 2 equal to sigma 3, which means sigma 1 can now be replaced by, let us say these sigma 1 equal to sigma 2 is equal to sigma 3 can be written as sigma. So now I can replace sigma 1 with sigma, sigma 2 with sigma 3 with sigma in x bar, and similarly I can replace with replace with and I can replace in which coordinate? In y bar, right? Okay. Now, okay, my bad. You found out the mistake. So this also should be equal to sigma, right? And now if we have sigma in both numerator and denominator, we can take sigma common out of the brackets. So I can like rewrite the entire expression like this, right? Rewrite the entire expression like this. Okay, wait, there is a minor mistake here. What is that? The mistake is that these terms should not be having sigma, right? Okay, sorry for the minor algebraic error here. This should be sigma instead of sigma 1. Okay, now what is sigma by sigma? It is 1. What is sigma by sigma? It is 1. Therefore, what is x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. And similarly, what would be y1? You can write down that rule. Okay. Now, since that we have calculated x bar in terms of a1 and x1, let us now try to find out the answer for this question, for this numerical here. So all the calculations, all the previous calculations for the center of mass for figure 1, figure 2 and figure 3, they remain the same. The x bar coordinates x1, y1, x2, y2, x3, y3, they do not vary no matter which formula you use. But what varies here is instead of m1, we need a1. Instead of m2, we need a2. And instead of m3, we need a3. So let us look for the calculation in detail. So this is the first figure. That is the first figure. And the length here is 3, the breadth here is 1, or the width here is 3, and the height here is 1, which means area will be 3 into 1 equal to 3. And what is the corresponding x1? It is 3 by 2. I'm doing the calculation only for x bar. You can do the same calculation for y bar. And let's see if we get the same answer. For the area 2, width is 1, height is 1, so the area will be A2 is equal to 1 into 1, and x2 is 1 by 2. Like I said, I'm doing the calculation only for x2. You can do the same for y2. And for area 3, we have length is 1, width is 1, height is 1. Therefore, area 3 will be 1 into 1. x3, we have calculated this earlier as 5 by 2. Now, if we have x1, x2, and x3, and a1, a2, and a3, what is x bar now equal to? X bar will be equal to a1 x1 plus a2 x2 plus a3 x3, the whole upon a1 plus a2 plus a3. What is a1? It is 3. So we have 3 into x1 is calculated already. So it's 3 into 3 by 2 plus 1 into 1 by 2 plus 1 into 5 by 2, the whole upon 3 plus 1 plus 1, 5, which is 3, 3, 9 plus 1, 10 plus 5, 15 by 2 by 10, which is 15 by 2 into 5, which is 15 by 10, which is 1.5, right? And if you see, this overlaps with the previous method where we use x bar in terms of m1 x1, and we get the same answer 15 by 10. Okay, so I have not calculated the value of y bar here. Try using the same method and find out the value of y bar. And if you have any doubts, please feel to get back. Okay, right. So now we discussed a solution for one question in two different ways using two different formulas. One, m1 x1 plus m2 x2, and the other one a1 x1 plus a2 x2, and we have discussed in detail how did we arrive at these two formulas and the way of applying them by calculating the individual center of mass of these bodies and then trying to find out the composite figure the composite figures coordinates of center of mass. I hope that makes sense. Now that we have discussed these two methods of doing the question, let us spend some time in understanding the significance of uniform section and to find out the method of finding center of mass in detail. Okay, so those who are pretty much okay with the concept, and if you feel that you need only the numericals, then we can skip the next solution and go to the we can skip one solution and go to the next question. Otherwise, if you feel that the calculation of the center of mass is a bit, it's kind of a trouble to you, then maybe we can troubleshoot that. We can sit and understand the process in detail. Okay.